Ladies and gentlemen, please welcome to stage the president of Linux International, John Mad Dog Hall.
Thank you very much. Once again, it is a pleasure to be here at Campus Party. And my talk today is called A Comprehensive System of Education Using Free Software. Now, I give talks all over the world. As a matter of fact, I've been to over 100 countries, most of them more than one time. And I often start off my talks with this slide, because there's one thing that every single one of these people have in common. It's not that some of them are multimillionaires. It is not that some of them live in very poor countries or very rich countries. But the thing that every single one of these people up here have in common is that they have done amazing things in the software field without ever having any education, formal education, in computer science. I'm only going to pick out one of them and talk to you about that person. The person in the lower middle corner, the black man with the striped hat. I met him in a city in South Africa called Soweto. Soweto was a very poor black city of about 500,000 people. And before apartheid, they were basically people who serviced Johannesburg with the white population. After apartheid was over, Soweto started to develop, but it was still mostly a city of very poor black people. I went there with a former resident of Soweto. He was showing me around the city. And I said to him, I believe that even in Soweto, there's people who know about free software. And he said, no, I'm sorry, that's not true. I was born in Soweto, I was raised in Soweto, and I know there's nobody in Soweto who knows about free software. So I went back to the airport and flew home. And to his credit, he went and talked to his boss in the government and said, he told him what I said, and his boss said, let's go see. And so they went to Soweto and they had a talk about free software that they advertised. And 350 people showed up to the talk. In the front row were three young black men, and they were arguing with each other. And they said, what are you arguing about? And one of the black men pointed at him and said, he runs a consulting service out of his house using dial-up networking. And he is sending email to Linus Torvalds, helping Linus debug an error in the memory management subsystem of the AMD processor. And this so impressed the government of South Africa that they opened up an open source development center in Soweto. I'll introduce you to one more person. This is a guy who lives in a favela in Rio de Janeiro. A favela is a very poor slum. And he was selling trinkets on the beaches of Rio de Janeiro at the age of 8. His mother was also selling these trinkets, trying to earn a living. And he said to himself, if I buy the trinkets in the low season, I'll be able to get them for a lot less money. And all we have to do is store them until the tourists come. And he told his mother this, and she started doing it, and yes, they made a lot more money. After a while, he decided that he wanted to teach himself computers, so he pulled a computer out of the garbage, took it home, cleaned it up, got it to work, and yes, he used free software on it. He taught himself networking, and after a while he said, I believe that I could sell wireless services to people in the favela. And all the people around him laughed at him and said, nobody will pay you for wireless services. He said, "I think I'll try." And to make a long story short, today, 6 people are employed by him full-time, providing wireless services in the favela. He applied to the government for a grant to teach web design and systems administration to the young people in the favela. And he said to me, "Mad Dog, they used to talk about guns and drugs, and now they talk about the internet and computers." What are the goals of education? A lot of people think that you go to university to get a good job. That's not the goal. The goal is to create a thinking electorate. It's to create a thinking workforce. It's to teach you how to learn for yourself and therefore create a lifetime of knowledge. Once you graduate from university, you should never have to go back again for a refresher course. You should be able to pick up information from magazines, from the internet, from talking with people. And of course, another goal of universities is to do research, public research with public money, in order to further the knowledge of humankind. And sometimes there's private research that is funded with private money. But even then, a lot of the knowledge comes from people who have been funded by public money. So a certain part of that knowledge should also be public. I used to teach full-time. To a large extent, I still continue to teach. And when I look at what a university or a college does, they typically set a path of objectives. In other words, you go to their web pages or you look at their syllabus, and they can show you what courses they think you should take in order to have the knowledge that you need to accomplish your chosen field. After they show you that path of objectives and what order they should be taken in, they then teach to those objectives. After they've taught the information to you, and after you've researched the information yourself, they give you tests to certify that you've actually know that information. And finally, they research new objectives, because over time, some of the things that you need to get through life change. Now, a lot of people come to me and say, "Mad Dog, do I have to go to a university for education?" And I think that the people on those first slides, the answer is no. However, education at a university can open up new doors to you that are unique, because you meet a mixture of different people, and you meet a lot of very, very bright people who are, have interests the same and different than yours. But there are also other methods, other ways of getting education. For example, cooperative education, where you go to school part-time and you work part-time. I was a cooperative education student in Philadelphia in 1969, and it was because of the cooperative education that I switched from being an electrical engineer to computer science, because the job I thought I would be doing as an electrical engineer is not the job I would have been doing. And I went into something that I thought was a lot more fun. Another type of education program, and one that's been practiced here in England for over 500 years, is the guild program. The ability to become an apprentice, then a journeyman, and then a master craftsman. And that's a perfectly viable method of getting an education. You can also get an education by finding a mentor and studying underneath of them. And you can also do the self-learning route. And finally, probably the best way of learning something is to go and have to teach it to somebody else. I flunked compiler theory the first time I took it. Of course, back in those days, it wasn't compiler theory, it was compiler black magic. The second time I took it, I did pass it, but you know, when you're studying something and you're taking a test, you can make a decision. You can say, well, I don't quite understand that, but they probably won't ask a question like that on the test. And even if they do, I could get one or two questions wrong. But then you have to teach it to somebody. And that's the time you're really terrified, because you know the thing that you don't understand will be the first thing that they ask about. And so when you have to teach something to somebody, that's the time you have to know it forwards and backwards. I've taught compiler theory about 10 times in my life. And even though the last time I actually had to teach it was over 15 years ago, if you take me out to the bar tonight and put a whiteboard in front of me, I'll give you the fastest 10-minute course of compiler theory you've ever seen. Give me a couple more beers, I'll make it 5 minutes. So what do we teach and not teach in today's academic environment? I can tell you what we shouldn't be teaching. We should not be teaching Cisco networking. What we should be teaching is networking standards and implementation, with Cisco as an example. We should not be teaching Microsoft Office. We should be teaching how to use Office systems to run your business better, with Microsoft Office as an example, OpenOffice as another example, maybe K-Word as another example. We shouldn't be teaching Oracle database, because if we are, then when Larry Ellison brings out a new version of Oracle, I should go and grab your diploma back, because you don't know anything more. Or when the next edition of Microsoft Office comes out, I should take back your diploma. How many of you know a company called Nortel Communications? Yeah, Nortel Communications was at one time the second largest telephone company on the face of the earth. It only took them about 6 months from going to that position to bankruptcy. And if you had gotten your Nortel Communications certification, then you would be out of luck. But if you had been taught telephony, with Nortel as an example, you probably also would have seen other examples. Now, what is free culture and how can it help? We have free and open source software. First of all, it frees you up from having to pay the licenses for the software. A lot of people say, well, Mad Dog, in your university, they give us the software. You know, we have these companies give us software and we can use it as university students. But there's a slight problem with that. What happens when you, as a university student, want to use that software at some type of job, whether it be a cooperative education job or a part-time job? Your university license typically doesn't cover that situation. So legally speaking, you'd have to go out and buy a copy of the software just for that. And certainly when you leave the educational environment, you will have to pay for the software that you've been learning in university. This is a slight problem. A lot of times I go to certain countries like Brazil, and I say to them, you should be using free and open source software. And they say, Mad Dog, all of our software is free. In Brazil, they pirate 84% of their desktop software. In Vietnam, they pirate 96% of their desktop software. I don't really blame the Vietnamese because the average Vietnamese person only makes $4 a day. And Microsoft Office costs them $400. If I was in their boat, I would probably put a patch on my eye and go, RRR, matey. But it's more than just the software itself. It's a study of the creation of free and open standards. How do you create a standard that allows longevity of the software as well as interoperability of the software? It's the concept of Creative Commons, the sharing of digital data, digital music, digital graphics. And then finally, free and open source hardware, which we'll see a little bit more later. There are actually distributions of Linux which specialize in education. Fedora, as an example, which is the user and free and open source version of Red Hat software, has a special version of their Linux system put together with all of the tools that they need for teaching from kindergarten to 12th grade. Edubuntu is another distribution that's used by a lot of schools. In Brazil, they have a special distribution of Linux called Poseidon Linux, which deals with scientific, engineering, mathematics, and it's in a variety of different languages. But let's take a close look at what you could be teaching in a university with free and open source software, and particularly in a computer science curriculum. Let's say you want to teach operating systems design. You could start with an operating system called FreeDOS. It's a binary compatible program that's compatible to MS-DOS, but you could get all of the source code for it and see how this simple DOS system actually works. How is it put together? How does it handle interrupts? How does it write to a file system? And then once you've seen this simple operating system, you can then study different kernels, like the Linux kernel, like the BSD kernels of FreeBSD, NetBSD, and OpenBSD. And people say, well, what about Minix? And I think that Minix is a wonderful educational operating system. But when I was studying operating systems back in 1969, I knew that the operating system that I wrote by punching out cards was not going to be used by any serious company. And all of the time that I spent in studying and working on that operating system really was not going to benefit me that much when I went out into the real world. In the real world, people use Linux. In the real world, people use BSD. And so you could be learning how the operating system works with an operating system that's used in 98% of the world's fastest computers. You can see an operating system that is embedded into more than half of the smartphones shipped today. You can see an operating system which is used in half of the server systems being shipped today. You can see how it works. You can study it. You can learn how to write device drivers for it. And if you're interested in how a microkernel works, you can take a look at CMU Mach or the Herd microkernel. And these are not simple toy operating systems. They're multi-user, multitasking, 50,000, 100,000 tasks at a time. Multi-CPU. Some of the world's largest supercomputers have hundreds of thousands of processors working together, and they use the same kernel that I'm running on my notebook right here. It's multi-architecture, so you can see how to take an operating system and move it across architectures to make it portable. It's 32-bit and 64-bit. In fact, Linux was 64-bit in 1995. And the first time that Microsoft had a true 64-bit system was Vista. If you're interested in how file systems are created, Linux supports every file system I've ever heard of. All the FAT file systems, NTSC, Unix file systems, log-based and journal systems. Also network file systems like NFS and Samba. All the types of networking I've ever heard of, including proprietary networks like DECnet, have free and open source implementations, so you can study how the network stack is supposed to work. If you're interested in security, Linux supports a variety of different security models. SE Linux stands for Security Enhanced Linux, and it was actually developed by the NSA because they wanted to have a truly secure system. I know you're laughing about that. It is ironic, isn't it? But the thing is, if you depend on obscurity to give you security, you've already lost. There's another security model called AppArmor. And AppArmor has a different model that's interesting to look at along with SE Linux. Kerberos is a network-based security model. The Linux system supports the X Windows system from MIT, a client-server type of system, as well as OpenGL for 3D graphics. In clustered systems, we have the support for high-performance computing. We formerly called this Beowulf systems. And also highly available systems. In case one system goes down, the other one takes over. A lot of people are interested in virtualization these days, and we support two different types of virtualization. One called Xen, which, by the way, was developed at Cambridge in England, and KVM. We have a wide variety of different emulators that you can run. But FOSS, free and open source software, is not just about the operating system. Let's say you're just studying compiler design. The GNU compiler suite supports all the different languages I've ever heard of, as well as the interpreters that are used in the web: Python, Perl, Ruby, TickleTK, and I'm sorry I forgot PHP on this. We have database engines that are open: MySQL, Postgres, CouchDB, all of them available in source code form. Office systems we mentioned before. Multimedia tools, different implementations of codecs for you to look at, as well as tools for video editing, audio editing. Voice over IP, be able to make telephone calls over the internet, as well as Asterisk, which is a phone switching system, probably one of the most sophisticated in the world. And if you go out to this place called SourceForge on the net, you'll find out that there's over 430,000 different projects out there that are being worked on by over 3.4 million developers. And people say, "Oh, Mad Dog, I've been out there, and some of those projects seem to be dead. Nobody's working on them." Okay, think about this. What would happen if the software was done? In other words, it does everything it's supposed to do. Why would you change it? Well, if you want to sell people another copy of your software to make more money, you would change it, maybe needlessly. Maybe make it even bigger and bloated so that you'll force them to buy a new computer at the same time. But if it's done, and you really are not going to make any money by changing it, then you just leave it alone. It's done. What a refreshing thought. And the other thing is, people say, "Oh, there's a lot of CD players out there, and how many CD players do you need?" And, you know, only 10% of those projects are real. That's fine. That's still 43,000 different software projects out there. And even if they're out of the 3.4 million developers, some of those people only work on those projects 10% of their time, that's still 340,000 people working on those. Now, believe it or not, when you are a software developer for a large company, you don't actually work on things 24 hours a day. You have to go to meetings, then there's coffee breaks, then there's playing foosball, and all the other things that are important. And let's say you're working for a large company, and I won't spell any specific company out, but it sounds a lot like Microsoft. Microsoft has 70,000 people working for it. And out of those 70,000 people, 24,000 of them are in sales and marketing, and therefore have no useful value. Of the people, I can say that because I'm also in sales and marketing. I understand, I can say that. But of the people that are left, not all of those people are software developers. Some of those people paint lines on this driveway, and some of those people are security guards, and some of those people work in the cafeteria, and some of those people put software into boxes, and other people take software out of boxes. And so when you get right down to it, if I was to guess, in a company the size of Microsoft, probably about 7,000 people actually bear the title of software engineer. Compare that to the 340,000 people, if even that's just 10% of them working. And this is without the rest of the countries of the world being fully attached to the internet. And when that happens, that number will grow dramatically. And people go, okay, Mad Dog, I'm not really interested in an operating system or compilers. What other types of stuff is out there? Large amounts of things. Audio and video programs, which you mentioned before, but programs to also run your business and your enterprise. Open ERP systems, CRM systems, web page design systems, systems for home and education, games, science and engineering, and security and utilities. All sorts of different programs are out there, and they're all organized so you can see what you're looking for. But another interesting fact about this is that you don't need to use the entire program. Let's say you're trying to design something new, and you say, what I need is something like MySQL does. You can go into the MySQL source code, pull out the part you need, and use that in your solution. On those websites and in those mailing lists of these projects, you can meet other people who have a like interest to what you're doing. And these people are very open and friendly most of the time, and they will help you with their concepts and with information to help you make your project better. And because you're using already existing code, your research and your programs will be developed faster than if you had to write everything from the beginning. Here are more things that we should be teaching in today's universities and even high schools. We should be teaching fundamentals of how does a computer really work. Unfortunately, I go from university to university these days, and there's this group of professors that say, the only thing they really need to know is Java. Wrong. They need to know how the computer really works. And the professors say, oh, no, they don't, because of all the levels of abstraction that are there. I says, no, they really need to know how the computer works. And at this point, I'm going to put an advertisement for my talk tomorrow at 8 o'clock about performance. And I invite you all to come to that. We should be teaching people how to compare various pieces of software, various operating systems, and pick out the right one for the job. And we should be teaching people how to share ideas and to be able to work as a group. We should not be teaching specific products. In the new web-based environment, we should be teaching people how to do distributed development, how to work with people you don't see face to face, how to license software the proper way, and how to understand if the licenses meet your needs, how to develop formal standards, and then how you innovate above the standards and below the standards. Above the standards, you're innovating in your application and your solution. Below the standards, you're making the standard work faster in a more scalable, more efficient method. How do you motivate software developers? One time I was working for Digital Equipment Corporation, and I saw a piece of software an engineer had written. I went into his cubicle and I said, I want to tell you how great that piece of software was. And the man burst into tears. He said in 30 years, I was the only person to ever tell him that he had done a good job on a piece of software. This is a crime against God. How do you locate and engage a community of users and developers and help them or encourage them to help you with your project? And how do you innovate everywhere and always? These are the things that people really value. There's also free tools for teaching. LTSP, the Linux Terminal Server Project, is a favorite of mine. It allows you to put together an inexpensive, highly available server where all of your programs and all of your data sit. And then on people's desks, they have very thin clients, sometimes made up of old computers that are cast off from other places. The Atlanta public school system uses LTSP. They have 4,400 students with 2,200 desktop clients, 233 classrooms, but they use only 31 servers in order to run all of this with 4 systems administrators. So 4 systems administrators for 4,400 students. If somebody's laughing, I can hear you. Yeah, you're probably thinking we have 4,400 systems administrators for 4 students. In Curitiba, Brazil, there was a high school that had no computers or anything. They didn't have any money for them. So the teacher of the class went out to a bank and said, please give me all of your old computers that you're about to throw out, and I'll take them back to the classroom and I'll have my students pull them apart, put all of the pieces on the shelves, and then we will reconfigure those computers to be an LTSP system. And the students learned twice from that. First of all, they learned how to work with computers and everything else. But more importantly, they learned pride in being able to make their own computer lab. Here's another way that you make a very inexpensive computer lab. You can put an entire GNU Linux operating system on a flash-based pen drive. And then you can take and stick that into a computer that might be running some other operating system. And you can allow the student to work with the data and to store their data and their programs on the pen drive and then take it with them home around their neck. There's no licensing worries that you have a copy of the software here or a copy of the software there, because that's okay with free software. But as I said before, free and open source software is more than just the software itself. It's about open processes. The Free and Open Standards group of working on standards that are published, that are open, and the Linux Professional Institute, who certifies systems administrators. I'm particularly proud of the Linux Professional Institute because they're one of the organizations that I helped to start as part of Linux International. They publish goals of their certification tests on the web, and you can go to their site and you can follow those goals, those objectives. If you can honestly say to yourself that you can do every one of those things listed in their objectives, then you have the knowledge to be that level of systems administrator. You don't have to take the certification test. In fact, they have sample tests that you can take just to prove to yourself that you know the information. So I have known people who have trained themselves to be Linux systems administrators by going to the LPI website, following the objectives, learning the information. And they never paid any money to LPI. I also mentioned that there's more than just open standards and open software. There's now coming open hardware. And I know that most of you are familiar with the Arduino and the Raspberry Pi. I'm also very proud to say that the Raspberry Pi was developed at the University of Cambridge, and the same place that the EDSAC computer was created many, many years ago. But the Raspberry Pi is interesting because it's so inexpensive that if you burn it up or if you lose it, it's not heart-stopping. But it's what I do call the cheap computer for high school students, because there's another computer coming out that is what I would think would be more for a university student. It's a 2-core ARM9 processor that also has a field programmable gate array on the same chip, along with some digital signal processing chips, along with either a 16 or 64 core processor, where each core has its own megabyte of memory. So you can program this to do parallel applications. The whole board draws only 5 watts, and it costs only $99. All of the specifications for making all of the board are available at the website of the company, Adaptiva. These are the types of things which are going to allow students like you to develop really amazing projects. And so what I say to people like you, is a challenge for this region is to gather in groups with mixed abilities and skills. Maybe an electrical engineering student, a software computer science student, a business student, a manufacturing student, and have you create a proposal for new products. Choose all the groups of the products, choose the best ones, and then go ahead and develop a prototype with that. Then take it out to a company and say, would you like to manufacture this? Because manufacturing is where you create the real wealth. Manufacturing something, creating a product, creating a service, is where the real wealth is created. There's another part of this free software model which is called Creative Commons. And it has a very simple licensing model. You'll notice on my slides that every single one says Copyright Linux International. That's because I wrote the slides, and I should have the right to say what happens to them. But you also see on every single slide a little thing at the bottom, which is the Creative Commons licensing. And it says, you can take a copy of my slides and you can send them to whoever wants to see them freely, without money. And that's my choice of licensing them. You can have, there's a lot of people that don't even know about Project Gutenberg. Project Gutenberg has over 39,000 free books that you can download in textual form. And it has pointers to another 100,000 of them. So why would anybody buy a classic novel like Tom Sawyer or Huckleberry Finn or Charles Dickens when you can download it for free? And the same thing is true of photographs and music. In Brazil, there's a new style of music where the bands will play at a concert and they'll hook a CD recorder into their soundboard. After the concert's over, they'll take that CD out to the music pirates and they'll say, make and sell as many copies of this as you want. The music pirates will sell it for about $1 a CD. But when people hear the music, they go, that's really good. I'm going to go to the next concert. And they go to the next concert. By that time, the band has cleaned up the CD, done editing on it to make it better, put it in a real jewel case with some pictures and autographs, and sell it for 10 times what the music pirates sell it for. They're using the music pirates to advertise their band. You have to look for the new business model. The old business models may not work anymore. So today, even the student who has no money can still find a college curriculum on the internet. They can find the objectives of that curriculum on the internet. You can find the information you need to learn that information, to learn that objectives from places like the Khan Academy or the system put up by MIT, Stanford, and Rice universities of publishing all of their lectures on the internet. You can learn everything you need from the internet. And people say, but what about the diploma? What about certification? If you want a formal diploma for systems administration, you can go to LPI. But there's also informal methods of certification. When I graduated from college, we had what we called a portfolio of programs. The portfolio were the programs that we had written, and we showed those to our prospective employers. We got letters of recommendation from the part-time jobs that we had had. So what I recommend to you as you're going through university is that you join a free software project. You find something that interests you, and you start to follow their mailing lists. You start to look and fix bugs in their system and submit patches to them. And after a while, they'll start to notice you. And they'll say, would you like to join our development team? And then when you do that, you keep track of your contributions you've made. When you're about to go out and look for a job, you can ask the team for letters of recommendation. And make sure that as you work with them, you also give praise where praise is due. Remember the engineer in the cubicle who hadn't been told that for 30 years. Now you can take your portfolio and show it to prospective employers. Mark Shuttleworth, the person who started Ubuntu, wanted to pull together some people, so he took the entire Debian mailing list and the entire Debian source code tree on his laptop down to Antarctica for 6 months. And he sat in Antarctica just looking at who had good ideas, who submitted good code, who didn't argue with a lot with people. And when he came back, he said, I want you and you and you to come work with me on Ubuntu. He didn't have to call any HR people. He didn't have to search in the newspapers. He knew who he wanted. Now, if you choose to take a closed source job with a closed source company, you can't really show a portfolio. They won't let you show their source code to a prospective employer. They won't let you show the mailing list to somebody because what they create is done behind closed doors. And by the way, when you start to set up your business, a recommendation is you form a cooperative. Somebody working by themselves often is a very lonely position. It's very difficult to go on vacation or to, if you're sick. But if you have a cooperative, a lot of times the people in the cooperative can take over for you. And you can also share resources such as salespeople, legal people, administrative help. Large companies would rather work with a cooperative as a company than a single person. So with that, this is the end of my talk. I hope I've showed you that you can get a real education, in computer science at least, by utilizing free software. I point out that when you use closed source software to teach somebody something, then you're teaching them how to use the software to solve a problem. And that's fine. But when you use free software, you not only teach them how to use the software to solve a problem, but because they can look at the source code, they can also learn how that software solves that problem. And finally, if they work to improve that software, they can learn how to work with other people to make that software solve that problem. So free software teaches 3 times, not just once. Thank you very much. I'd like to answer any questions I can. Maybe we can bring up the house lights a little bit so I can see people.
Thank you very much for a very illuminating lecture. I'm Chris Maffin and I lecture computer science. What I want you to really find out from you is the new model of the Brazilian music pirate. Does that equate to beta testing of software, or is it really open source?
The nice thing about free software is that most projects are developed completely out in the open. So if you're starting up a project, almost from the very beginning, there are people who look at it, give you comments back on it. The Linux kernel was developed very rapidly because they would put out new versions of it and 10,000 people would pull it down and try and work with it and come back with the bugs. So there was a rapid feedback mechanism of how good the kernel worked. And that's true of most free software projects. Now the kernel system is a lot more mature these days, and there isn't as huge a percentage of the people to pull it down, but there's still enough people who pull it down every day, or every time there's an incremental update to it, that the kernel development group gets the feedback very quickly. So I believe that the open source model of developing software is very, very good in that respect. It's one of the reasons why the Linux kernel is as stable as it is. I don't know if I answered your question or not. You're shaking your head yes, okay.
How difficult is it for a developer going into open source software if they've got a project which is taken off or become successful? How difficult is it to manage maybe good-natured but over-eager contributors who maybe are submitting things which might break stuff or hasn't been reviewed properly? I mean, how do you balance open source with sort of open access and who can actually change the source?
Well, again, what I suggested, particularly if you're a new programmer going in, is that you first sit there and read the mailing list. You'll see how the rest of the developers interact with people fixing bugs, people putting in problem reports. And actually, I would even start off by, there's a skill at putting in a good problem report. I used to get these problem reports like, it broke. Well, what do you mean by it broke? What do you mean, how did it break, And not only that, but what architecture are you talking about? What version of the code are you talking about? Where's your data stream to show me so I also can produce and test this. So the first thing you want to do is start to understand what it's like to be a developer on that project. And then you can take and say, can I create a bug fix for this? Now, most projects have a list of bugs which are outstanding, a list of feature requests which are outstanding, and some type of priority order on them. So you can take one of those bugs, fix it, and what you try and do in that case is you try and make your coding style fit the coding style of the code that's already there. And then you submit it. And I would recommend that you steel yourself just in case the developers that you submit the code to are maybe a little rougher than you might think. Most of them are not, and most of them recognize your level of skill and ability and your wish to put stuff in. And, they might say thank you very much and take it, or they might say thank you, but it would be even better if you did this, which gives you a second chance to put it in. And over time, you'll get to be better and better at this. Actually, one of the people who now is one of the main kernel developers for the Linux kernel started this way, just giving bug fixes in over time. I had a friend of mine who wanted to work on the Apache web server. He started the same way, giving patches to them, and over time, they brought him into the core developer group. So it really is a way to do it. And I also suggest you pick a project that you feel passionate about. If you like music, pick a music project. If you like medicine, pick a project in health or medicine. You can link together your knowledge of your knowledge of computers with something that you also have another interest in. Next question.
Hello, I really like your talk, but what I wanted to say, out loud, that might be not heard these days, that corporations are going to open source, protocols and specifications of language and compiler source and so on. And even that Microsoft that you mentioned does that right now. With open data protocols and so on. And it might be not that fast, transition from closed source to open source. But I do believe they are going there. And my real question would be, for the open source developers, okay, the code is open source, everyone can watch it. And, use it and make it better. But then what to do for the developer in India or somewhere else where he cannot sell his code? I mean, he doesn't know that or something how can he live from that code that he contributes to open source projects only?
Okay. How many of you have ever gone down to a computer store and bought a box of software and taken it home and put it up on the wall like a shrine, maybe with 2 candles on either side? You don't buy software for that, right? You don't buy. I mean, you might do that with a picture, because a picture is a product. But you don't do that with software, because software actually is supposed to help you with a solution. People buy software and hardware for solutions. Maybe the solution is you're playing a game. Maybe the solution is you're trying to do some type of work. But it isn't the software that you're buying, it's the solution. there's a lot of companies that for a long time said that free and open source software had a higher total cost of ownership than closed source hardware or software. And the reason they said that was that it was hard to find people who knew free software and could help them with free software. So even though the software itself was without royalty, over time the support costs were higher because you had to pay more money to get these free and open source people to work for you. I'm going, help me with this. Companies, you're telling me that we should really be training all these students on how to do free and open source software because they'll earn more money than the ones that are doing closed source proprietary software? No, that's not what we meant. Yes, it is. You said that. But what you really need to consider is that the person in India is selling a solution to somebody in India. And he's going to take all this free and open source software and put it together and help that customer with a solution. And the solution, the total cost of ownership has a level. If you can't afford the solution, then you're not going to have it. And that's true whether you're using free and open source software or proprietary software. But after you've gotten past that point, there's another thing you have to be thinking about, and that's called return on investment. If I have $100 that I'm going to invest in something, and that $100 gives me a solution that's only worth $1,000, but I take the same $100 and put it in another solution and it gives me $10,000, then that's the solution I should be buying. So it's the value of the solution that's the most important thing, not the cost. Okay? And I think that open source gives you a more valuable solution. Why? Because you can make certain decisions that with closed source, the decisions are taken away from you. You can say, I'm going to stay with this solution I have right now, and I'm just going to fix little bugs that appear from time to time. I'm not going to have to upgrade from one version of the operating system to the other just because the vendor is telling me to. I'm going to stay with the solution that's working. In Brazil, there was a bunch of banks that had automatic cash machines, ATMs. And the operating system that was in these machines was called OS/2. It was created by a little company called IBM. You may have heard of them. And IBM decided they were no longer going to upgrade OS/2. They were going to retire it. But all of these banks had old 386 systems, 486 systems, low-end Pentiums, and they needed to have an operating system for it. And certain large company in Redmond didn't have anything that could help them, so they looked at Linux. And Linux did run on the 386s, the 486s, small amounts of memory. And so the bank used that. And today, on the front of every single one of those ATM machines, even though it's 10 years later, there's this tiny little penguin to thank the Linux community for creating Linux for them, because it saved them hundreds of millions of dollars. It's a solution, the value of the solution. Caixa Econômica Federal in Brazil said they were running the lottery system by using closed source proprietary software. They were paying $1 million a month maintenance on that software, and they didn't mind because they were making a lot more money than that. They decided to go to free and open source. And when they went there, they found out that they could create a new game not in 10 months like the old system, but in 3 weeks. Do you know how much money you make in a country of 194 million wild Brazilians who like to play the lottery? And when you have the new game 9 months and 1 week early, you make a lot of money. No. A lot of money. A lot of money. It's the value of the solution. One other thing I like to tell people. It is very unlikely that the person in Vietnam who makes $4 a day is going to be able to afford a solution written by a U.S. programmer who's getting paid $200 an hour. Weighted salary, folks. But the person who's in Vietnam could go down to a local university, find a student and say, could you just make this little change for me? I'll give you 2 6-packs of beer. That's known as getting support on your own economic level. Actually, in Hanoi, Vietnam, you can buy a nice glass of beer for only 10 cents. It's called fresh beer. So for $10, you could buy 100 glasses of beer. You do that after he's fixed your code. So it's the value of the solution and the economic situation. Okay? So this is how you make the money with free software, by selling a solution, not a product. Okay? Next question.
Hello. Unfortunately, we ran out of time now.
Okay.
Thank you.
Thank you.
Applause.
Hang on to my heart. You keep me moving forward. Hey. Oh, it feels so crazy when you